let me show you how to take the derivative of e to the x. So let's start out with e to the x, and let's try to figure out, so this is my f of x, and let's try to figure out what's the derivative, what's f prime of x. And so as we're in this part of the course where we're figuring out for the first time what these derivatives are, we really have no other recourse but to go straight back to the definition. And this time I'm going to use the definition of limit as h goes to 0 instead of x goes to a. I'm taking the derivative of the function at the point a equals x, if you like, and that's going to be limit as h goes to 0 of f of x plus h minus f of x over h. So let's just expand this out. Let's plug in e to the x for f of x. Let's see what we get. So I'm going to be plugging in x plus h, giving me e to the x plus h minus e to the x all over h. So I have to figure out what to do with this. So first, by exponent rules, e to the x plus h is e to the x times e to the h. And then let me factor out that e to the x, giving me a limit as h goes to 0 of e to the x times the quantity e to the h minus 1 over h. So you see what I did there, I just broke this up to e to the x times e to the h, and then I factored out e to the x. And now as I'm taking the limit as h goes to 0, so h is the variable here, x is like a fixed constant. You're fixing x, you're taking the derivative at x, and the way you're doing that is you're letting variable h go to 0. And so our constant multiple limit law says that actually you can bring that e to the x back to the outside. You're going to get limit h goes to 0 of the function e to the h minus 1 over h. And how do you calculate this? Well, you can try plugging in h equals 0. You're going to get e to the 0 is 1 minus 1, so you're going to get 0 up here. You plug in 0 down there, you're going to get the indeterminate form 0 over 0. So how do you figure this out? Well, this is a question that we're not really equipped to answer quite yet, because in order to do that, I actually need to tell you what's the definition of E, and then substitute in the definition of E, and then do a little bit of manipulation and figure it out. But just for the purposes right now of finding you a formula for the derivative of e to the x, what I'm going to do is a graphical investigation of this limit. And so actually I've found the graph of function e to the h minus 1 over h using Desmos. I'll show it to you right there. And what you can see is that as those x values are getting close to 0, those y values are getting closer and closer to 1. So in fact, that limit through graphical investigation using the computer software tells us that limit's equal to 1. So this expression just turns out to be e to the x. And that proves to us that the derivative of e to the x is e to the x.